Okay, hi. So my name is Simi Korea and my student ID is X2332018. Okay. Okay, so let's discuss my thesis project on localized deepfake detection, enhancing authenticity verification in Irish media, specifically for Ireland. So I have a question. Which of the three images looks like Tom Cruise? Do you think all the three images are real or okay, so you might have thought that the first image is real or maybe the third image is real, but let me tell you, surprisingly, all the three images of Tom Cruise are fake. None of the Tom Cruise is real. So nowadays, deep fakes are generated in such a way that even human eyes cannot tell if a particular person is real or fake. There was a case with Sharon Tobin. It was shown that in the Irish Sun newspaper 2024, Sharon Tobin's deepfake was used to advertise for an investment scheme, and a lot of people got trapped into that scheme. They invested a lot of money into it because they felt that it was suggested by Sharon Tobin, but it was fake. She has reported that into the newspapers. Now, the problem statement is deepfakes are used for misinformation. They are used for political manipulations. There are a lot of growing threats. A lot of people get calls and they ask for money, or they threaten you by using your photos for some illegal stuff, and then they threaten you by asking money for not publishing that out. So deepfake detection is causing a lot of chaos and a lot of issue in the market. Now, even though there are a lot of detection techniques available for deepfake detection, they are mostly built on a global data set like Face Forensics Plus Plus, DFDC. All of these data sets include people from all over the world. And also, secondly, the data sets that are there, they are mostly having celebrity figures into them. So when a particular model is fed an unseen image, it tries to not respond very well in that case. So my research question is, how can a region specific detection model be used to deal with the deepfake detections for a particular region, say Ireland? So if I build a data set for Ireland specifically, will it help me in giving deepfake detection, detecting the deepfakes accurately, then having a general model for it? So for this, I reviewed all the literature reviews that were there. It is divided into four parts. First one was the machine learning based approach. I found out that most of the models were overfitted. There was a lot of difference between the training accuracy and the testing accuracy. It was found out that SVM works best with 99.5% of the accuracy. Transitioning from ML to DL, when deep learning comes into picture, it is always a high computational cost. The findings were that exception net, efficient net, and the vision transformers performed very good. Now, multimodal based approaches here, they use images and then add audios to the image. They lip sync the image and create a video, fake video out of it. And it was observed that multimodals outperform unimodals, but the gaps were that the audio video synchronization issues still remain unsolved. And for region specific detection, there were only two papers. One was Korean based, one was Asian based. The gaps were, it was not, obviously, it was limited for global applicability because it was built on a region specific data set. But the findings were that when they were trained on a region specific data set, it gave better results than training it on a global data set. Data collection. So I divided my data collection into two parts. First one was I tried to collect 50 fake and 50 real images from the trusted media sources that were available online publicly. So I used RTE, The General, Guardian, IFTN, etc. All these websites were used for collecting fake and real images. And in the phase two, since just 100 images wouldn't be enough for a model to be built, I generated synthetic fake images using stable diffusion v5 model. Here I tried to keep equal proportion of males and females by writing the scripts accordingly. And for real images, I use this person does not exist website. Now, what this website does, it gives you how a particular person would look like if so for example, I told it to generate images that were having Irish ethnicity and equal proportions of male and female of so and so age group, and then it gave me that. So the raw real images look like the ones on the left hand, and the ones that were generated from this person does not exist look like these. Now, in the research approach, firstly, for phase one, I pre-process the data set. I resize the image into 224 cross 224. Then I converted it to tensor by red, green, and blue. And then I normalized all the pixels so that the model does not favor any particular pixel, and then use data augmentation, flip and rotate techniques, and then a pre-trained ResNet 18 model was built. And for phase two, the same data pre-processing techniques were used, and three different models were used. One was a basic pre-trained ResNet 18. Second one was balancing the weight and optimizer for ResNet 18, and the third one was EfficientNet B3 model. Now let's see what results did we get. So for module 1, that was ResNet 18 with 50 real and 50 fake images, we got the training accuracy of 97.5%, which was very good. But then the testing accuracy dropped down to 80%. So it dropped down by 17%. There was a lot of gap between training accuracy and testing accuracy, which suggests that the model was overfitted. Even if we look at the gradcam visual, it looks like the model is trying to focus on the facial expressions, but it is focusing more on the forehead area, and it is also focusing more on the neck area, and it is not actually capturing the eyes and nose of a particular person. So this was the phase 1 of the analysis. In phase 2, I compared these three models, and this all these three models were built on the 400 images that were generated synthetically and also the real ones that were used. So we found out that EfficientNet outperformed both the ResNet models in both precision and recall. So for recall, for real, it gave 83%, and recall for fake, it gave 95%, which was good enough. If we look at the GradCam visual from EfficientNet, now we can see that it actually looks at the facial features of a particular person instead of looking at the other body parts. It is capturing the eyes, cheeks, nose, lips, etc. very well. Now let's look at the ethical considerations. Even though all these websites were available publicly, I still went ahead and tried to read their terms and conditions, because because complying to GDPR was very important to me. And I collected only the data set only from the websites that mentioned that it could be used for research or thesis purposes. No PII was collected, that is, no personal information of a particular person other than their photo that was available publicly was collected for this analysis. The real and the fake images were stored into different folders labeled as real and fake, so that there is no mixture of photographs happening. In the stable diffusion model, the output for the stable diffusion, the output that was generated from the project was kept only for the project purpose, and it was not used for anything else. Let's look at the conclusion and future work. So our first point was to generate an Irish specific deepfake data set, and we were able to generate that, and it was GDPR compliant. We generated 400 images for Irish specific data set. Then we found out that EfficientNet outperformed ResNet 18 models. And for future work, I am planning to expand the dataset and also create multimodal deepfake detection datasets by synchronizing audio and video. Thank you.